Hello and welcome to day one of your last unit. This is actually going to be your last video for the year, so enjoy it. We're going to look at solving differential equations, and the one thing that you've already done this in one of your weekly questions, so it should not be completely new to you, but let's look at what we're doing. So differential equations is involving one or more derivatives of an unknown variable. And the order is the highest derivative that it contains. So the steps are right here. You're going to make sure that the y's and dy's and x and dx's are together. We're going to integrate both sides. We're going to attach the plus c to the x side, solve for y, and then use the given information to solve for c. So let's look at what this looks like. So the first step is make sure we get the variables correct. So we'll put that over 1, and we're going to get dy equals negative 4xy squared. And we'll notice, dx at the end there. We'll notice that the dy is here, so we have to get the y squared over. So we'll get dy over y squared, I divided it, for x dx. So there's step 1. The next thing that we're going to do is integrate. So we'll integrate both sides. Now, we can rewrite that as y to the negative second dy. We will get y to the negative 1, put a negative 1 out in front since we divided by that, equals, well, we know it's negative 4x squared over 2 plus c. So we're going to get negative 1 over y equals negative 2x squared plus c. So even though it does say number 4 solve for y, sometimes, just so you guys know, we do like to switch up 4 and 5. I actually think it's easier, so if we want to just make that a 5 and then a 4. Solving for y or solving for c right now does help you. You don't have to worry about then making sure when we solve for y that c is in the correct spot. So right now I'm going to solve for c. And so I'm going to get negative 1 over 1, this is your xy, equals negative 2 times 0 squared plus c, and therefore we can see that negative 1 equals c. So we're going to finish up and solve for y with using the information that c is negative 1. So I'm going to get negative 1 over y equals negative 2x squared minus 1. We could do this whole idea of cross multiplying, get the y on this side equals negative 1, and then divide everything over. But when you see that it's negative 1 over y, you can reciprocate. So I'm going to get y equals negative 1 over negative 2x squared minus 1. And that's your answer. You are done. You solved the differential equation. And that is it. Why don't you guys try this one, only this one, using the steps we just did, and I will come back with the answer, and we'll see how you did. And so the difference here that you saw is that you had no initial condition or condition point given to you, so there is no way to solve for c, which is what I wrote right here. With that, when you solve for c, there is another way you could write this, and you could have written it as y equals the fourth root of 4x cubed over 3 plus c. This is your answer, and hopefully you got that right. Let's try this one here. So we have 1 plus x to the fourth y dy equals x cubed dx. Well, we don't like that, so we'll divide it over. X cubed over 1 plus x to the fourth dx. So we've got our variables together, so we'll integrate now. And this side is easy. But clearly we can't make all these easy, so we do have to figure out how to integrate a fraction. The only way we know how to integrate is either by trig inverse functions or by u sub. and therefore we're going to look at u sub here. So our u sub, u is going to equal 1 plus x to the 4th. Du will equal 4x cubed dx. And we do not need the 4, so we'll put the 1/4 out in front and get the integral of 1 over u du. Well, so we'll get y squared over 2 equals 1/4 ln of u. Well, we know what u was 1 plus x to the 4th plus c. And then we need to get this 2 to the other side, so we'll get y squared equals 1/2 ln of 1 plus x to the 4th plus c. And so our final answer, when we square root to get rid of the square root, we'll get plus or minus the square root of 1/2 ln, the absolute value of 1 plus x to the 4th, and the plus c again can stay out in front. So for this question, bear with me as we're going along. You may need to stop, pause it, think, or rewind. But what we're going to do, I'm going to go through this. 3 tan y equals dy over dx secant x. We don't like that we have dy over dx, so I have to multiply it over. 3 tan y dx equals secant x dy. We also don't like that the y's and x's are not together, and therefore we will divide by the tan and secant to the other side. So I'm going to get 3 dx over secant x equals dy over tan y. With this, I'm going to also make it so I'm going to have 3 cosine x dx equals cotan y dy. Reason why I did that is just so I don't have the fractions. Now, when we look at this, you're going to sit there and say, well, I can easily integrate the first part. I'm going to get 3 sine, negative 3 sine x plus c. But how do you integrate cotangent? Well, if you look up here, cotangent is cosine y over sine y. And if you let u equal cosine y, or sorry, sine y, then du will equal cosine y. And therefore, when I look at this, I'm going to get the integral of 1 over u du. Well, the integral of 1 over u is ln of u, so therefore, what I'm going to get is the ln of the absolute value of sine, because u is sine y, okay, just the absolute value of sine y. Now, we don't have a condition to solve for c, so therefore we're going to solve for y. Well, when we solve for y, I have to get rid of the ln, so I'll e. So e to the negative 3 sine x plus c equals sine y. This is something that the AP loves to do, is when I have anything, let's do x to the 2 plus 5, that's really x to the 7th. I can rewrite that as x squared x to the 5th. It's the power rules, where when you add, you're really multiplying. It's the same idea here. I don't like the c in the exponent, and so therefore I can have e to the c, or I'm going to write e to the c here because it doesn't matter, e to the negative 3 sine x equals sine y. Well, e to the c is just a number, and so therefore it's just c. It's just a constant, c. It's the same idea that I talked about over here when you square root, or in the one before, when you square root c, it's just still c, it's still a number. So we get to this part, which looks a lot nicer. So this is it's the power rules for, or exponent rules, excuse me, the exponent rules. So we get here, how do I get rid of the sine supposedly? Well, I'll take the sine inverse. And so I'm going to get c e to the negative 3 sine x equals y. And there you go. It is done. I know that was not nice, but it worked out well. I would like you to pause the video right now and attempt this one, please. So what you will see here made y prime dy dx. We then move the dx over. I factored out a negative e to the y, thought that would make it easy. So I knew that 1 over negative e to the y was negative e to the negative y. Use u sub if you need to, but you're just going to get 1 over e to the y. And integrated here. We solve for c, and then solve for y. Notice that it's not the absolute value because you're not taking the integral. Okay, so we use parentheses, not the absolute value. It's a common mistake there. So you get 2 over the ln of 2 over x squared minus 1 over 2x plus 1. If you would like to try the last problem, you're more than welcome to. And so when you know it says the slope, you know it's equal to dy over dx, you solve for c, solve for y, and you get the final answer of your final video of the year to be y equals the cubed root of 3x squared plus 27. Enjoy it, and I hope you enjoyed your last video. We have one more day of notes, and then it is on to review for the exam. Have a good one.